Dear all, I would like to welcome you all in the lecture series of Basic Electrical Engineering. In this session, you will be able to learn how to solve numerical example in case of parallel AC circuit. We have done one problem based on parallel AC circuit in the last session. There is another variety. This can be expected for your university examination. First of all, I request everyone to go through the particular problem. So please read the question carefully. So let's read the question. Two impedances 150 plus J157 ohm and 100 minus J110 ohm are connected in parallel across a 220 volt, 50 Hz AC supply. Find the total current and power factor. Please make it power factor. Alright. What you can do is you can draw the diagram like this. So we have two impedances now. So first one is Z1, right? So Z1. What about Z2? Yeah, you can able to mark it as Z2. I think you are getting my point. Both are in shunt or parallel, no? Yeah, Z2. There is a supply voltage. Let us say this is your total current I. As soon as we provide the supply, there is a total current which is flowing in the particular circuit. You know this is a parallel circuit, therefore current is getting divided. Because this is a branch now, two branches are there, so current is getting divided. These currents are I1 and I2 respectively, of course. So our ultimate goal is to calculate what is the total value of current. Yes, once you get the total value of current, then you can able to calculate the power factor. I will tell you how to calculate. So let us move on to the solution. Let us assume that I1, I2, these are the branch current where I is the total current. So our ultimate goal is to determine the total current I. Before that, how do you calculate I1? Can you think that how do you calculate I1? You know this is a parallel circuit, no? Okay, I1 according to Ohm's law, I1 is equal to V by Z1, V by R. In the DC circuit we will be saying that V by R, but in case of AC circuit we call it as impedance, no? Yeah, V by Z1. If it is better to write in polar form, we already discussed polar form. So V means V angle 0 degree. And also Z1 means set angle theta degree. Am I right or not? Okay. Z angle theta or 0, anything you can assume, no issue. Z angle theta or Z angle, whatever it may be. Z angle theta is better. So V divided by Z1. Okay. So what you can do is, what is voltage V? Please refer the diagram. So voltage V is already given. Let me mark it. This is your total voltage, because total voltage will be same for all the branches because it's a parallel circuit. Okay, am I right? And Z1 is already given in the question, 150 plus J157. This is also merely visible in the diagram. Yes, and also please read the question. So 150 plus J157, which is the form? You tell me. You can tell me which is the form. Obviously, the form is in rectangular form. 150 A plus IB. Okay, A plus JB or IB. That is rectangular form. What you can do, 150 plus J157 need to be converted into polar form, R angle theta. So what I have done is I have used the calculator. I told you already how to convert rectangular to polar and vice versa. See, anyway, no problem for numerator. Voltage means 220 angle 0 degree. But denominator means Z1 angle theta, no? So 150 plus J157 has to be converted into polar form. What could be the polar form? 217 angle 47.306. Please verify it once. You can do it manually as well. So what you can do is do the operation. How to do the operation? R1 angle theta 1 divided by R2 angle theta, it is nothing but R1 by R2. You can do that first. 220 by 217. What about theta 1 and theta 2? Since it is a division operation, so you have to subtract theta 2 from theta 1. So therefore we can write theta 1 minus theta 2. What is theta 1? 0 degree. Theta 2 means 46.306. So I can do the subtraction. So 220 by 217, how much it is? Please calculate it. 1.0138. You have to verify, please. So 0 degree minus 46.306 degree. That will be minus 46.306 degree amps. What is the unit of current? Of course, it's ampere. I hope it is clear. Till this step it is okay. Likewise, what you can do is you are supposed to calculate I2. Of course, we can calculate the I2 in the same manner as that of I1. How did you calculate I1? I1 you computed by using the formula V by Z1. Likewise, I2 will be V by Z2. V will be constant only because it's a parallel circuit. What is V? 220 angle 0 degree. What is Z2? Z2 means 100 minus J10. It is given in the question, please refer the question. But 100 minus J110 is a rectangular form. You are supposed to convert rectangular form into polar form for your convenience. So 220 angle theta degree 0 degree, not theta 0 degree. Okay, because it's only magnitude is given. Therefore 220 angle 0 degree divided by 148.66 angle minus 47.72. Now as I said earlier, you can do the operation. How do you do the operation? 220 by 148.466 should be done first. This operation has to be done first. Direct division, magnitude R1 by R2. Then theta 1 and theta 2 is there, no? Therefore theta 1 minus theta 2. So what could be the value of minus theta 2? Theta 2 means minus 47.72. Theta 1 minus theta 2 become theta 1 plus theta 2. Obviously the answer become 47.72. Please calculate it, then you will understand. Okay. So this is actually the value of I2. Now please, everybody please refer the circuit. As far as the circuit concerned, we can say this is your total current I, okay, and I will be divided into I1 and I2. Actually I forgotten to write I1 and I2, so just that's why I am writing once again. So I is equal to I1 and I2. So according to KCL, what you study in KCL, according to KCL, incoming current will be always, sum of incoming current will be incoming current will be equal to the sum of outgoing current at a particular node or junction. All the incoming current and outgoing current, sum of incoming current will be equal to sum of outgoing current. So same principle you can apply. I already received the value of I1 and I2 by doing the calculation, I1 and I2. Please everybody please go through that, definitely you will understand. So this kind of questions can be helpful for your competitive examination also. Okay, anyway, it is typically I made it for first year students, I1 plus I2. So I1 and I2 you have to add. See, total current will be I1 plus I2. So while adding now, it is convenient to convert polar into rectangular. Already polar form is we already converted polar, right? We already received in the form of polar. But addition, during the addition now, it is not convenient. So it is better to convert polar into rectangular. Use the calculator. I already explained it. Or else manually also you can convert. Now then it is very easy. Add a real part. The real part. What about the imaginary part? These are the imaginary part that you can able to operate. So final answer comes 1.73 angle 12.14 degree. So this is actually the polar form. So what is the procedure means? First polar form is available. Do convert polar form into rectangular form because it will be convenient for doing the addition operation. Once you got the final value of rectangular value like 1.696 plus j 0.365, then what you can do? You can convert into a polar form again. Yeah. Now listen very carefully. So current is actually available in the form of polar form, right? Ultimately we convert into polar form. Now listen carefully. So this will be in the form of R angle theta, correct? Okay, this will be R angle theta. So yes, now what you can do is draw the phasor diagram. So what are the parameters you know? I1 you already know, right? Then I2 is already available. Then I is the resultant value. I means I1 plus I2, vector sum of I1 and I2. Now anyway we already taken, it's a parallel AC circuit, right? So what we have done is we have taken V as a reference because voltage is common. Now tell me what is power factor? Power factor is nothing but cosine angle between voltage and current. Cosine angle between voltage and current. Now tell me the answer. Answer is very clearly available. So it's an angle between voltage and current. Okay. So that angle you are supposed to calculate. Let us come back to the problem. Please refer the phasor diagram once again. We have already explained. In case any confusion, please put up in the comment box. Surely I will revert. Yes, we have drawn the phasor diagram. Then I told you that power factor is the cosine angle between voltage and current. Anyway, we got the value of phi. Phase phi is available. Then can you take cos phi? If you take cos phi means the answer will be power factor. So cosine of what? Cosine of 12.14. Please take the cosine of 12.14 degree, obviously you are able to get 0.997. That is the value of power factor. I hope you understood how to solve the problems related to parallel AC circuit.